So here we go again. Today we're going to start looking at angles, not angles, triangles, sorry. We have had this before, I know you have, because I just went over this with the 5th graders. So 3 different kinds of triangles we're going to talk about today. Pretty simple. An equilateral triangle has all 3 sides the same length, and all the angles in that triangle would all be the same measurement if we were to measure them all. And they will indicate that all 3 are congruent, or all 3 are the same by these little tick marks on all 3 sides. An isosceles triangle on the other hand, only has 2 congruent sides with 2 congruent angles. This would be an angle, and this one right here, these 2 would be congruent. A right triangle is obviously a triangle with a right angle. This is a really easy lesson, so we should be able to get through this one pretty quickly. Alright, let's fill out number 1. So a triangle has how many sides? Ooh, that's a tough one. A triangle has how many degrees? Well, if you were to add up all 3 angles of any triangle, no matter what its shape or size, you would always end up with 180 degrees. A circle, on the other hand, how many degrees is in a circle? 360 degrees. The sum of the angles in a square is how many degrees? Well, let's think about it. We have a square. These are all right angles, right? So that means they're all 90 degrees. So what would 90 plus 90 plus 90 plus 90 be? Did you get 360? Good job. I'm writing these little degree signs, and I probably don't need to because I already have the word right there. A triangle has how many interior angles? Interior means inside. So a triangle has 1, 2, 3 interior angles. An equilateral triangle have how many congruent sides? Well, these little tick marks tell us that all 3 of them are congruent. An isosceles triangle only has 2 congruent sides. And a right triangle would have 1 right angle. It can only have 1. Alright, let's identify these triangles. The tick marks will help us tremendously. The 3 tick marks here tell us that this is equilateral. I'm going to turn my laptop to the side here so I can write a little bit neater. Alright, the 2 tick marks tell us it's isosceles. And the little right mark there tells us that this is a right triangle. Okay? Measure these angles. Remember, all 3 angles should have a total of 180 degrees. So this one I'm not going to be able to do with you. The only one I can tell you for sure is that this one would be 90. I can pretty much guess. You can measure these, but if you measure these two are going, I'm pretty sure, in a right angle. The other 2 have the same, not this one up top, this one doesn't, but this one looks like they might have the same. My guess is they're going to be 45 degree angles, because you have to, not 45, that wouldn't work. No, because we got to get 180, don't we? Yeah, forget what I said. 90. Yeah, that would be right. Yeah. I'm thinking they're 45 degree angles, but you might want to check to make sure. This one looks like an equilateral triangle to me. So my guess is if you have a total of 180 degrees in a triangle and you have three sides that are all the same, if you divide that, you'll get 60 degrees. I guess I could look in my book, but I'm not going to tell you. This one right here is way off. You're definitely going to have to measure that one. And what you're going to do is you're going to use your protractor and treat them as angles. So you're going to want to extend them. So like extend that one and measure that one. If you want to, you can pause and like extend these guys and measure that one. And then measure that one. Did I already do that one? Maybe it's this one you gotta do. Anyway, you're gonna want to measure all three of them. All I can tell you is if you get two of them, you can just take the two that you do know, add them together, and subtract them from 180 degrees to get your third angle. All right, now my second page to this one is far down my list, so just bear with me while I try to find it here. I think that might be going backwards. Let me go this way. I don't know how it got out of order. Well, I take lots of pictures, can you tell? Oh, no, I should have went the other way. And this doesn't look anything like the way it's saved on the computer. Are we getting there? Oh, that's the one is that the one we were just on? Yeah. Language, lots of language. Okay, what's this one? 130. What was that one? 131. I think I'm getting warm. Oh, I think this is it. No, that's 133. Let me get this back. I don't know. Here we go. I know I have it. I saw it. Where is it? I might pause it and look for it for you guys. 131. But that's I'm looking for 134, right? Let me get to the end here. That's 135. 35. This is it. Is this it? Yes. Okay. There we go. All right, so write the number of degrees in the third angle of the triangle. So just add up the two. We have 45 and 70. Can you add that up in your head? Did you try it? Did you get 115? At that point, take 115 and subtract it from 180, because that's how many degrees are in triangles. And I get 65. What about you? I'm going to slam my iPad or my tablet again here. All right, 65 plus 25. What is that total? Try that in your head. Get 90. 90 plus 90 is 180. 90 plus 30, 120. What's 180 minus 120? We can do that one in our head, I think. Just think 18 minus 12. 6 out of 0. Okay. 37 plus 69. Can we do that in our head? How about 106? Am I right? I think so. No. Yeah, I think I'm right. All right, so 180 minus 106. 74 degrees. The book agrees with me. 99 plus 135, well, 100 plus 100, 100 plus 35 would be 135. So it'd be 134 from 180. You get 46. Good job. And then finally, 43 and 71. What do you get? That you can do in your head. You don't have to do any carrying or anything. You should get 114, 114 from 180. 66 degrees. Pretty easy stuff. Draw angles. Draw angles with these degrees and then bisect them with the compass. Ho, here's the tough one. Let me just remind you how to do it. Okay? I'll talk you through one, and then maybe you can do the other two on your own. You can pause if you need to, because you're actually doing it, and I'm just going to talk you through it. Alright, so the first thing we're going to do is we're going to draw an angle. I'd highly suggest you just do this on a piece of paper. So you make your dot, make your ray. Okay? If you do a nice big one on a piece of blank paper, then it'll be easier to use your protractor. Mark your 40 degrees with your, put your protractor on there, right? Protractor's on here. Mark, start with the 0. Go up about 40 degrees, put a dot. At that point, take a straight edge, ruler or your protractor, and make the other side. Okay, after you did that, get rid of this part right here. Then take your compass, put your metal point right here on your vertex, and then swing it around the pencil side and make an arc right through there. Remember this from the other day? Now take your protractor and measure from here to here. Make your protractor fit right here. After you do that, put the metal part on one of the dots, like right here, and then swing it around up top to make a little arc inside. Then put your metal part on this one and swing it around. Where they intersect should be the center, and you can take a straight edge and go straight up through it. Okay, that was kind of fun. A little tedious, but fun. And it'll be a lot more fun if you use it on a whole sheet of paper, so you got lots of room to play with it. Okay? Alright, measure these angles and label them as obtuse, acute, or right. Alright, I can't really measure them with you, although I do know this one right here is a right angle. So how many degrees is it? Very good, 90 degrees. So we would call that a right angle. This one is smaller than a right angle, so I know it's acute, and I know this one's obtuse. What degrees they are, you're going to have to find that out. Just remember, extend, so you can get a more accurate measurement. You can even extend this if you want. Alright. Down in the review, this is really quite simple. Remember, we're doing perimeter on this one. They go back and forth, that's the only trick. This one's perimeter, this one's area, this is circumference. So let me write you the formulas with you. The perimeter of a square is just all 4 sides added up, or 4 times the side, right? So you're going to take the 4, put it over a 1, because this is a fraction up here. I believe I can put my thing up to a light. Is that 1/3? 6 1/3? So what is that as an improper fraction? To get 19 over 3. 19 over 3. I don't see any cross canceling. So you're just going to multiply that out. Make sure your final answer is as a mixed number and it's reduced. And the answer would just be in feet because that's perimeter. Area, on the other hand, of our rectangle is length times the width. And your answer is going to be inches squared. Circumference of a circle is either pi times diameter or pi times the radius times 2. This gives you the diameter, so you can use this one right here. Remember, pi is 3.14, and you'll times that by 9. And that also will just be in feet because you're just doing the length. These down here look pretty simple. I think you guys got these. You could really, for this, keep life simple. Just do n 9 times 4. What is 9 times 4? 36, right? Now put all 3 of those zeros in the front. Now, how many numbers do you have after the decimal with both numbers? This one has 3, this one has 2, so you have a total of 5. So 1, 2, 3, 4, 5. That's where your decimal goes. Yeah, no need to multiply with all those zeros. Just put them in when you're done. Get in the habit of doing that. It makes life easy. All right. I think I've gone over everything. Pretty simple lesson. Do a couple of the things that I didn't do with you, like these bisecting with the compass. Do that on your own. Don't forget to get the measurements for these 2 angles that I didn't give you. All right. I will talk to you guys later.